I think this is the one that really exciting to me. When you're thinking about semiconductor technology, certainly there are opportunities today that you can address. And India, strategic opportunities, if you're looking at e-learning, and really coming up with ways to be able to revolutionize education systems. And if you're looking at the opportunities in energy, and if you're thinking about Jawaharlal Nehru solar mission, basically having 20 gigawatts by 2020, so inverters really don't need 28 nanometer technology. If you're looking at health and education and health, I believe are going to be disrupted in a big way across the globe in the next 10, 20 years. And India can play a very significant role with the idea of frugal innovation, developing products for Indian context, but really adding value to them to be competitive in the global scene. There is another way to think about semiconductor technology. This is something I firmly believe. This is the idea of precision materials engineering. If you're looking at semiconductor technology, it is nothing but your ability to manipulate matter with atomic precision. If that is a core strength, you can solve many, many fundamental problems. If you're looking at electric cars, there is really a need for solid-state batteries. Nobody is really a global leader today, but it certainly can be done. The fundamentals have been actually proven in the scientific domain. How do you build an automotive system based on solid-state batteries, which would be 20% in volume compared to lithium batteries? If you're looking at LED technologies and its effects with respect to energy conservation, if you're looking at solar technology, if you can come up with 50 cents per watt, you can be the global leader in reaching grid parity in every part of the world. So the opportunities, I think, are tremendous when you're thinking about electronics industry and its foundational technology, what we call precision materials engineering. So how do you create a viable ecosystem? So you certainly need to have a market. You can address with end products. You need to have companies that can design these products, manufacture, and sell them both in India and outside India. And you need to have a supply chain, the likes of Applied Materials, Air Liquide, Air Products, setting up shop and providing specialty chemicals, providing state-of-the-art equipment, and making these fabs run smoothly. And government, of course, should play a role with respect to helping with the infrastructure. And academic institutions, I think, are already stepping up with the investments Government of India has made, and the Indian nanotechnology network, both at Indian Institute of Science and IIT Bombay, with the state-of-the-art fab equipment, providing solutions for faculty and students across 70 to 80 universities to be able to do world-class research. So how do you go from a viable semiconductor system to a sustainable semiconductor system? So if you're looking at a viable system, commercial entities play a role in products, and academia play a role in developing talent, and government plays a role in being able to provide the infrastructure. And both the proposals are bringing in knowledge, whether it is IBM or ST, providing the technology, Silterra and Tower Semiconductor, and then you're addressing the markets today, you're addressing the markets that are going to be there tomorrow. But then if you're looking at a sustainable ecosystem, you really need a semiconductor R&D center that we believe. Again, semiconductor technology is R&D intensive. Pharma, and healthcare, basically. If you're looking at these three industries, they spend about 15% or more of their revenues on R&D. So the R&D center would be an enabler. I think multiple people talked about the idea of entrepreneurship. You need to have a state-of-the-art facility where entrepreneurs would be able to take advantage of the technology and exercise the design roles. You want to be a global player. So maybe I can give you some examples of how other countries have gone down this path in creating a sustainable ecosystem. So this is the example of ITRI, and ITRI was actually instituted in 1973 And currently, as you can see, it's got about 6,000 people, 1,400 PhDs and 3,000 masters, about 20,000 patents. And entrepreneurship, startups is a big metric for many of these institutions, and it's got about 225 startups. And collaboration is another theme as well. So maybe I can give you a couple of other examples. I happen to got involved, or I certainly happened to see some of them take place. So if you go back to IMEC, which was instituted in 1984, and they get about 20% of their funding from Belgian government. By any definition, I think IMEC is the leading R&D center for semiconductor technology across the globe. If you're looking at IME, it actually started with one of the Bell Labs guy, Bill Chan, going to Singapore, starting this in 1991. And they are the global leaders when it comes to wafer-level packaging technology. Today, again, it has put Singapore on the global map with respect to semiconductor manufacturing. Albany Nanotech actually technically started in 1988, although much of the investments happened around 2000 time period. And it actually started with a $1 million center from NISTAR, which is the funding agency in New York State. And they've been able to build that particular institution and get the appropriate investments. So Albany actually is on the global map with respect to semiconductor manufacturing. So this is my last view graph. Maybe I can make an analogy on semiconductor technology and creating a viable ecosystem. So silicon wafer is basically the foundation, and air market is the foundation if you're actually looking at ESDM landscape in India. And transistor is heart of the device, and products are very critical to creating a sustainable ecosystem. And if you're actually looking at dielectrics and interconnects, dielectrics basically, you don't want to have any shorts or gaps. So I think this is where government can play an important role with the policy and infrastructure, and fab is basically your interconnect to be able to connect all these different systems. And the R&D center, I think, plays the role of packaging. So you're hermetically sealing this, and you're coming up with a durable product, and you're coming up with a marketable device that is profitable. So the theme again is made in India, consumption to creation, and we made a mock-up of a chip made in India, and hopefully this becomes a reality very soon. So I want to give you three messages if I can. The first one, I think we are at the tip of the iceberg if you are looking at the opportunities that are going to be created with the electronics industry. Not just meeting the needs of today, but being a global leader with frugal innovation, but really looking at the future, Internet of Things. And look at the adjacent markets, semiconductor technology, the idea of precision materials engineering is fundamental to solving some of those critical problems. And the last one I think other speakers have talked about. It is about having a vision, it is making investments, and it is an expensive proposition. And if I can close my presentation by saying something we used to say in academia when I was in academia, if you think education is expensive, try ignorance. So I think it's very critical to be able to do it. Thank you.
Thank you, Dr. Om Nalamasu, for your address.